To the next module. In this module, we will cover the Newland's law of octaves and the feature of Newland's law of octaves. Now, after the failure of Dobryn's triad, the next attempt to classify the element was done in the year 1864 by this English scientist who goes by the name of John Alexander Newlands. By this time, 56 elements were discovered, and Newlands arranged all these elements in the increasing order of their atomic masses. Some of these elements that were included in his table were hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium and calcium, to name the few. So he took all these elements and he arranged them in the increasing order of their atomic masses. He also studied the physical and chemical properties of these elements. So for his consideration, he took the first element, hydrogen, studied the property, kept it aside. Went for lithium similarly, beryllium, boron, carbon, nitrogen and oxygen, wherein he realized that hydrogen, lithium, beryllium, boron, carbon, nitrogen and oxygen do not have any similarities in the property. So they were placed one after the another in a horizontal manner. But when he came to element fluorine, he realized, or he found, that the property of fluorine was similar to that of the element hydrogen. So he placed fluorine below hydrogen. Similarly, he placed sodium below lithium because of similar property, magnesium below beryllium, aluminium below boron, silicon below carbon, phosphorus below nitrogen and sulfur below oxygen. Same went in for chlorine below fluorine, potassium below sodium and calcium below magnesium. Now once he arranged all the elements that were known to him, he found that the property of every eighth element was similar to the first. For example, if hydrogen is the first element, then fluorine becomes the eighth element, and both their properties are similar. So he kept similar elements one below the other. But did you know that Newland was also a music fanatic? And he found music in his element. He compared his elements to the musical notes, wherein if we go as per Western musical notes, we will find the 7 notes, but repetition, it comes to 8 notes. For example, do, re, mi, fa, sol, la, ti, do. Likewise, if we go to Indian classical musical notes, we go like sa, re, ga, ma, pa, dha, ni, sa. So we started from sa, which is the first note, and we ended at sa, which is the 8th note. That means the first note and the 8th note, they sound the same. Likewise, the first element hydrogen and the 8th element fluorine, their properties are similar. So Newland realized these are just like the musical notes. These are just like the 8 musical notes called as octaves. Hence, Newland's law is called as Newland's law of octaves, wherein he said that when these elements are arranged in increasing order of their atomic masses, the property of every 8th element are similar to the first. Let us move on to the features of Newland's table. Newland during that time knew only about 56 elements. So he arranged those 56 elements. After calcium, every 8th element did not possess the property similar to that of the first, which should go according to the Newland's law of octaves. But after calcium, it was not found to be true. 2 elements with different property, they were placed in the same box. As you can see over here, cobalt and nickel are placed in the same box, and cerium and lanthanum are also placed in the same box. Also, he could not give the reason as to why they were placed together. The element iron, which resembles in property to the element cobalt and nickel, was placed far away from these elements. And finally, this table did not include any inert gases simply because they were not yet discovered.